This is a smartphone. This is a tablet PC. They are both digital computers to some extent. Digital computers' basic functions are logical operation and storage. In this lecture, we will take the MOSFET as an example to tell you how to realize logical operation by this simple element. Firstly, let's discuss this question. Why do we need a digital system? This is a common circuit that we've learned in the previous lecture about the idea of op-amps. It's AND. Now we derive the relationship between the input and output. This is RF, this is R1, and this is R2. Based on what we've learned last week, its output UO equals minus RF over R1 times U1 minus RF over R2 times U2. The given values of the three resistance are 12K, 2K, and 2K respectively, so the output is minus 6 times the sum of U1 and U2, which means that their coefficients are same. So it's a reverse adder that adds the two inputs together and amplify it 6 times reversely. Let's see the two inputs U1 and U2. U1 is a DC voltage of 0.5 volt. U2 is a sinusoidal voltage with 1 volt amplitude. The range of their sum is from minus 0.5 volt to positive 1.5 volt. Multiplied by minus 6, it changes to minus 9 to positive 3 volts. This is the ideal output. But in the real condition, noise is everywhere. If there's a noise in U2, since the circuit has no ability to resist the noise, the output amplifies the noise in U2 6 times. The output changes to this. The system is a typical analog signal processing circuit whose signals are all known showing in their original waveforms. It means that DC signal shows a constant straight line and sinusoidal AC shows a sinusoidal waveform changing with time. We can see the problem of the analog system is that noise makes signal distort like this. And the distortion may be amplified in the analog system. Well, let's think about this question. We want to amplify a AC signal supposed with a DC signal, which is a little complicated. Let's make the question simpler. What if we only use two values for the signal? The line between the sender and the receiver exists noise. Now the sender only sends two values, 0 or 1. If the signal is less than 2.5 volts, the sender sends value 0. While the signal is larger than 2.5 volts, a sender sends value 1. If the sender sends a signal sequence 0, 1, 0, the waveforms may be like this. The sent value is 0 here, 1 here, and 0 here. Because of the existence of the noise, a received signal is distorted like this. If the signal is less than 2.5, the received value is 0. If the signal is larger than 2.5 volts, the received value is 1. Then the receiver also receives the signal sequence 0, 1, 0. You may find the advances of the digital system is that it can suppress the noise to some extent, with the prerequisite that the noise isn't too large. This is 5 volts and this is 2.5 volts. The received signal is correct as long as the noise is less than 2.5 volts. Let's discuss the problems for the digital system after knowing its importance. The first one is the combinatorial logic, which means if we know all the inputs, we will know the output. The voting system is an example. There are 5 people vote for one thing. It can be done if it is approved by 3 or more people. We can use the combinatorial logic circuit to create such a system that can judge how many people vote for approval and provide the correct result. The second one is the sequential logic, which means its output is based on the input and its current state. The counter is the typical sequential logic. It should store its current value and the input. Then it calculates the output by adding them together. So it's a sequential logic. Besides, we are dealing with a digital system whose signals are all stored and operated in the digital forms, for example 0, 1. So we need the analog digital converter ADC, which can convert the analog signal into the digital form for the common analog signals in the real world. Of course, the signal processed by the computer or the signal system can be connected to the real world through the digital analog converter DAC. That's DAC's function. Another one is also important. Let's watch the signal waveforms in the sender and the receiver. The precondition for the same signal 0, 1, 0 in the sender and the receiver is that they are set to measure the waveforms at the same time here, here, and here. You may find that the whole system is measuring with the same time interval, which is a clock period in the digital system. In the PEC course, we will introduce the combinatorial logic circuit, the ADC, the DAC, and the clock signal forming circuit. The details of the digital system will be introduced in the digital electronic course. I need to point out that you will know the basic structure of the computer by grasping the 4 parts of the digital system.